Assalamu alaikum students. I hope you all are doing well. Students, today we are going to start unit 4, that is problem solving. This unit is related to the process of solving a problem. In this unit we will see that how a problem can be resolved in the best possible way, and what are the steps involved to solve a problem. And further we will also learn about flowcharts, that what is flowchart and why flowcharts are important, what is the importance or significance of flowcharts, especially from programming point of view, and how flowcharts are used to communicate the logic of the program to the programmers, and what is its importance, and what are the symbols used in the flowcharts, how these symbols are connected with each other, and what are the meanings of each and every symbol used in the flowchart. So all these things will be discussed in this unit. Let's see the introduction of this unit in the coming slide. Introduction. A computer program consists of a sequence of instructions. Yes, we already know that any computer program is actually a sequence of instructions in any programming language. Before writing a computer program, a series of steps and planned activities are used to perform the specific task. The overall purpose of this unit is to introduce the fundamentals of program development. So the purpose of this unit is to introduce the fundamentals of program development, means that how the programs are developed and what are the steps involved while developing any computer program. Those will be discussed in this unit. Problem solving. What is meant by problem solving? Problem solving is a tool which helps you to solve a problem. It is a cycle which involves searching for a solution of a problem. How it is a cycle, we will discuss it in the next slide, and I will show you a diagram which shows that it's a cycle. This process is actually a cycle which iterates itself to solve a problem or to give solution of a problem. If the problem is solved, then you have found a solution. If the problem has not been solved, then you start the process again. System development life cycle. Now this terminology is not included in your book, but this is very important for all of you to know this, that how this problem solving is actually a cycle. That cycle is called system development life cycle. Whenever we want to develop any software based system for our computer for different purposes, like for if we want to develop an information system for our school or college or university, or an information system which is used inside the banks, or information systems which are used inside the hospitals. Everywhere nowadays different types of information systems are used according to the requirements of that organization or institution. So all those software based systems, they are developed by using the system development life cycle. What are the steps involved? Those are, see, the first step which is involved while solving a problem, that is planning. We have to make some planning, that how we will solve this problem and what we need to accomplish actually, and how we will accomplish those things that are required. So the first step is planning. Then second is feasibility. Whatever we have planned, is it possible for us to accomplish or not? In feasibility we have to consider different things, like for example time, whether we have enough time to accomplish the task or the project. Or feasibility, we also consider the money, whether we have that amount of budget which is required for accomplishing the project or for completing the project, or whether we have the expertise to accomplish that task. So different things are considered in planning. Further, we do the analysis of the project from different aspects, whether the project will be satisfactory later on, or whether it will have some problems. All those things are done during the analysis phase. Then we perform the requirement engineering. What are the requirements of the project, which things are to be required, how much time is required, how much money is required, how much resources are required. So all those things are done in requirement engineering. Further, we have to design the system. What should be the layout of the system, how it should look like, and what should be the interface. So all those things are done in design phase. Then we come towards, after satisfying all those and these things, or deciding all these things, we have to start the coding of the software based project. In coding, coding is also a very important and difficult step in the system development life cycle, because it requires a lot of expertise in programming. So in that we have to decide which programming language we have to use, and what are the algorithms should be used, what should be the logic of the programming. So all those things are decided in during the coding phase. Then after writing the coding, we have to test the code by running the code, and to see or to observe that whether the code is running properly, whether the code is enough efficient to perform the tasks in time, or is there any problem with the code. Like for example, if the code has some exceptions, we have to handle those exceptions, and if the code has some errors, we have to remove those errors and bugs from the code. All those things, these things are done in testing phase. Once the testing is satisfactory, then we have to deploy the software or the system in real environment. And after deployment, we have to maintain the system with the timely, with the passage of time, because each and every system, whether it is software based system or hardware based system, it needs maintenance. It needs regular maintenance to perform the tasks. So maintenance is the last phase, and here we can observe that from each and every phase we can go back to the first step. For example, if we have made a plan, and then after the feasibility we have found that the plan that we are making is not feasible, it's not possible for us. So we can go back to the planning phase again and will change our plan. And if the plan is feasible, then we come toward the analysis phase, and we found something which is not possible for us in analysis phase, or which is not related to our requirements. So those are also can be changed and going back into the planning phase or feasibility phase. So that's why it is called a cycle, where we can move to the to any phase from any other phase or any other step. That's why it is called cycle. Once the project goes through all these steps till the maintenance phase, then here we can see that it is again moved to the planning phase, because while maintaining a software, maintenance includes updation of the software, or removing any bugs or exceptions or errors from the software, or adding some new features in the software. So that is also requires some kind of planning, feasibility analysis. All these phases are included while updating the software or adding any new features in the software based system. So that's why it is called a cycle. And after going through several cycles of this system development life cycle, the software or the system becomes mature
and error free. So this was just for your information that how the system is developed by using the system development life cycle model. So this was just for your information. You can also get some other information from the internet, and you can search it on the YouTube if you people are interested. But this is not included in your book. Okay, make a clear statement of the problem. The very first essential thing for solving a problem is to make a clear statement of the problem. If the problem is not clearly defined, it cannot be solved in a good manner. For better solution of a problem, the problem must be defined accurately, clearly, and in detail. Each and every major or minor detail of the problem must be explained and described properly. You first have to be sure that you are clear about what the problem really is. It is said that a problem well defined is half solved. So this sentence actually shows the importance of the clear statement of the problem. If a problem is not fully understood, it cannot be solved. So identifying the problem is the key part of the solution. For example, if we have got some health problems, and we take appointment with our doctor, but we did not explain our problem clearly to our doctor, so he cannot figure out the proper medicine for it. He cannot prescribe the proper medicine for it and the proper treatment for us. So describing the problem clearly and completely is very essential while accomplishing any task or solving any problem. Extraction from the problem statement. What kind of information that we can extract, we can get from the problem statement? The primary purpose of a problem statement is to focus the solution of the problem. For solution of a problem, the problem statement must be clearly described, as I told you. A good problem statement should answer the following questions. The first question that must be answered by a good problem statement is, what is the problem? This should explain the problem clearly or in detail. Second, who has the problem? This should explain who needs the solution and who will decide the problem has been solved. So the person or the organization or the institution who has the problem must also be explained or must be mentioned. What are the limitations? Limitations means that the limitations in terms of time, money, resources and technologies that can be used to solve the problem. So whenever we want to develop any system for us for solving our problem, we must have to mention these three things to the vendors or to the problem solvers. We must mention that what is the problem, who has the problem, and what are the limitations. For example, if our school is planning to develop an information system for our school, and we talk to some experts who can solve our problems, or to any software house who will build a software or an information system for us. So we must have to explain our problems to them, that what is our problem, what is the nature of our school, and what are the constraints that we have. Further, we have to tell them that who has the problem means that what kind of students we have. Some of the students are living in the boarding, some are day boarders, and some of them are day scholars. So they must know all these things about our school. Second, they must know the faculty members, the nature of faculty members, the departments. Second, what are the limitations they should know that how much money we can afford to solve this problem or to develop an information system for our school. So we must tell them about our budget for the project. Further, we have to tell them about the time, which is the time that we have to develop that information system, or to tell them that or to give them the specific time in which we need the solution of the problem. Further, we have to tell them about the resources we have, that the system, if the system requires 3 to 4 users for its maintenance or its operations, so we have to mention that whether we have 3 to 4 people or not, or whether we have that infrastructure for the deployment of that system or not. So all these things must be mentioned to the service providers or the vendors who are going to solve the problem for us, or who are going to build the software system for us. Further, the technologies which are required for the system, whether those technologies are available to us or not, or whether we can afford those technologies or not. All these things, all these limitations must be clearly explained while solving a problem to anyone. So these are the questions which must be answered by a good problem statement. See, problem statement means that first of all we have to explain the meanings of our problem, that what it is in reality, and further we have to define the things which are included in our problem statement and explain it. I hope all of you have understood this thing, that how we can explain a problem statement. These are the 3 questions that must be answered by a good problem statement. Okay. Extraction from the problem statement. In most general sense, a problem statement has some data called input. To solve the problem, it requires some form of processing on that data and produced its findings called output. So the problem statement that we produce, or that we give to the service provider, that problem statement contains some amount of input data, and on the basis of that input data they perform the processing and produces the output. There are some questions about these issues like input, processing, output, and we need to answer them. These are, for example, what is given? The input, and the input is given in the form of problem statement. Every problem statement might have some data. This data is very important for the solution. We should clear about this data, that is, what does the input represents, what kind of information it is. The problem statement must represent the problem clearly, and the nature of the problem must be represented clearly, and the input that we give in the form of a problem statement must represent the nature of the institution which needs the solution. Second, what kind of information it is, whether the information is alphabetic, numeric, or it should represent the nature or the kind of information clearly. What type does the data have? As I told you, whether the data is numeric, alphanumeric, or alphabetic. So it should be represented by the input. So these are the questions about the input we need to answer. What is processing requirements? One once we explain the input, then on the basis of that input they will decide that what will be the processing requirements for processing that data or input data. The processing usually involves a sequence of certain basic processing operations. These processing operations require the answers of the questions like how can the output be produced. Before processing the input data, we must know that what kind of output is required. How can the answer be calculated? We must figure out the algorithms and we must figure out the methods which are used to calculate the output. What mathematical expressions must be needed? Like for example, if the input is given, like if two numbers are given in the input, like 2 plus 2 and 3, and further we have been told that we need the sum of these two numbers. So before doing before processing that thing, we must know that how can the output be produced, means what should be the mathematical expression which operation should be used, and we know that the operation which will be used, that is addition, and the output which is going to be produced will also be a numeric output. So these are the things that must be figured out before processing. Now what is required? The output. Output is the result of the processing operations. For the required output, we must focus on the following questions. What is required output? How it is to be displayed? What should be the format of the output which is going to be displayed? These are the things these are the things that we can extract from the problem statement, that is input, processing and output. For example, here we have an example which says that suppose you are asked to enter two numbers, to add them and then display their sum as output. Now from this problem statement, this is the problem statement, consider it as a problem statement where we have been asked to enter two numbers. Now we know that numbers are actually numeric type of data. So that is the input. In input we have got two numbers. The input are two numbers. To add them, now adding these two numbers requires some kind of processing. So that is our processing step or processing phase. In processing, what we are doing, we are actually doing calculate the sum of these two numbers. We are calculating the sum of these two numbers in processing, and then in output display the calculated sum. So it's a very basic and simple example of solving a problem, a very simple type of problem which involves input, processing and output. These three steps are involved almost in every type of problem solving, and diagrammatically it can be represented like this. Remember that for input and output we use the same symbol, that is parallelogram, and the rectangle symbol is used for processing. We will discuss all these symbols in the coming lessons. So this is how it is represented diagrammatically. First of all, we have got the input, then the input is processed. Here in this example, as input, in input we got the two numbers, plus we got the nature of the operation which needs to be performed. Then in processing we combined these three things, that is two numbers and the operation which is of course an addition operation. So that is called processing, and after processing we produced the output, which is also a numeric value in this case.
Okay students, that's it for today. If you have any question, you can ask me in the comments. Don't forget to subscribe my channel Computer Tuition Academy. Thanks a lot. Take care. Allah Hafiz.